Assalamu alaikum everyone. Today in this video we're going to solve all the problems from numerical methods P3 starting from October 23 to the recent paper. Now if you guys want, you guys can purchase this mini worksheet where we are only focusing on the recent question papers, and if you want, you guys can also purchase the booklet from 2014 to 2024, which will be available from this first week of Jan or the last week of Feb. First week of February or last week of January, right? In order to purchase any one of these, the worksheet that we're solving in this video or the worksheet booklet, you guys have to contact me through my WhatsApp number. I hope the WhatsApp number is available, visible on the screen. Otherwise, this is my WhatsApp number. Okay, so we are starting with the question from October 2022, question 5. This is in numerical methods. Solving this 4 or 5 questions from numerical methods will be easier for you guys to understand the basics and patterns of these questions that are usually asked in the P3 question papers. So for this one, it says that a profit made by a company $P millions T years after the company started trading is modeled by the equation. This is the equation. It says that the graph P against T is shown in figure 2. This is the graph over here, and according to the model, show that exactly 1 year after it started trading, the company had made a loss of approximately 830,000 pound. Okay. It was already stated that P over here stands for million, right? That means whatever we get for P, I will have to multiply 10 to the power of 6 with that in order to break that down into simpler forms, right? So over here, after 1 year means that over here the time is 1, the value for your time is 1. So for part E, for part A in this case, we're going to just calculate P. It is just going to be 4, 1 minus 1 divided by 10, then plus 3 over 4 ln, then 1 plus 1, and then 2, 1 plus 1, and then whole square, and everything with a bracket again, right? So if I simplify it furthermore, I'm going to get 3 over 10 plus 3 over 4 ln. This is going to be 2, and this is going to be what? 2 plus 1 is just 3, right? So 3 square is just going to be 9. So 2 by 9. Now you're just going to write this directly onto your calculator. 3 by 10 plus 3 by 4 and ln 2 by 9, and that gives you actually a negative value, negative 0.8281, and if you multiply with 10 to the power of 6, you get your answer as negative 83, 80, so not 83, 82, 80 and 58, obviously in pound, right? This is a negative value. Negative value indicates that obviously this was a loss, and this is very close to your 83. So it was also stated that your answer should be approximately 83, not exactly 83. So we can roughly say that this is actually minus pound 82,8000 minus, right? That, like over here, this is a loss of 82,8000 pound. This is very close to 83, so they will accept it. And after this, they are saying that the manager of the company wants to know the value for T for which P is equals to 0. And now they are saying that you have to show that this P is equals to 0 when the value for T is within the interval 6 and 7. So we just have to insert 6 and 7 into the equation. That's it. So over here, if you want to find out the value for P when T is equals to 6, it becomes 4, 6 minus 1 divided by 10 plus 3 by 4 ln. Then you have 6 plus 1 divided by 2 into 6 is 12 plus 1 whole square, and everything under a bracket. If you calculate this one, then you are going to get a value of negative 0.087. It's a very continuous value, so we're going to write negative 0.088. And again, if I'm going to insert T equals to 7 into this, so it becomes 471 over 10 and plus 3 over 4 ln 7 plus 1 divided by 2 into 7 is just 14. 14 plus 1 is going to be 15, but I'm going to write this as just 1 minute. 6. 2 into 7 is 14. 14 plus 1 whole square, and then everything inside bracket. If you now calculate this one, you are going to get 0.197. So I'm going to write 0.20. What you can understand here, I mean over here only doing this part is enough, okay, but what you can understand is that between this value, like when t equals to 6 and 7, your value for p and value for p at 6, value for p at 7 changes a sign from positive to negative, from negative to positive. So obviously the value for t for which p is 0 obviously falls within this range of, or within this range of 6 to 7. So we can write that we have when t equals to 6, you got the value for p as negative 0.088. When t equals to 7, then you got the value for p as 0.2. There is a shift from minus sign to positive sign. That means obviously when p equals to 0 is somewhere over here, right? Is somewhere within the value of the range when t equals to 6 and 7. So you can say that there is a sign change and hence p is a continuous on 6, 7. So the root for t obviously lies within the range of 6 and 7. So you have to write down the statement that there is a sign change and hence p is continuous on 6, 7 lies within the range 6 and 7, right? So this is everything you need to do for your part B. After this, for your part C, it says that show that when p is equals to 0, that expression can be written in this format: 1 by 4, 15 by 8, ln 2t plus 1 whole square, and then t plus 1, okay? Let's see. For part C, we are starting with that your 4t minus 1 over 10, and then 3 over 4 ln t plus 1 and 4t. So it was not 4t, it was 2t plus 1 whole square. But as p was 0, so this equation is 0. If this equation is 0, then I can write 4t minus 1 over 10, and this entire ln part, we're taking that to the right hand side, so it will become negative. 3 by 4 ln t plus 1, 2t plus 1 whole square, and this is what we can write, right? So if I take this 10 to the right hand side, so we get 4t minus 1. We basically have 30 by 4 ln. 30 by 4 can be simplified actually. 30 by 4 is your 15 by 2, so we get 15 by 2 here already, and then t plus 1 and your 2t plus 1 whole square, right? And then after this, you take this 1 to the right hand side, so you have 4t, 1 minus 5, sorry, 1 will be positive, so 1 minus 15 over 2 ln t plus 1, 2t plus 1 whole square, and like this one. And again, if I take 4 to the right hand side, we get t. Like I'm going to basically divide everything with 4. So if I'm going to separately write 4 division with 1 and then 4 division with this, so you basically have 1 by 4, and 4 division with this means 15 by 2 divided by 4 is going to be 15 by 8 ln t plus 1, 2t plus 1 whole square with the bracket. Now if I scroll a little bit, this is a plus sign, right? And the entire fraction got inverted. That is because I am considering that this is a plus and we're taking that minus 1 as a common. Okay, if we have a minus 1 common in front of ln, that minus 1 will become the power of the value for ln, value inside the brackets of ln. So you can now write this as 1 by 4 plus 15 by 8 ln with this t plus 1, 2t plus 1 whole square, and then everything of this bracket with a power of minus 1, because we're taking this with the power of minus 1. And whenever we have a fraction with the power of minus 1, for example, a divided by b, with a power of -1, that leads you to b by a. So in this case, finally, I can write 1 by 4 plus 15 over 8 ln 2t plus 1 whole square divided by t plus 1, right? And that is your final answer. After this, nothing else. This is your part T. Right? This is the answer that I was supposed to show in this part part C. Then if I move on to your part D, where now this is your final numerical method iteration process, they have provided with a question that Tn plus 1 is the formula of this, where we're going to write Tn inside the question, and T1 is equals to 6. Find the value of T2 and T6, giving an answer to 3 significant figures. Okay, let's try to find out the value for T1 and T6. Sorry, T2 and T6, not T2 and T6. If T1 is 6, then T1 plus 1, which is 1 by 4 plus 15 by 8 ln 2. This is supposed to be T1 now, so 2, 6 plus 1 divided by 6 plus 1 whole square. That is going to be what? Over here, if I simplify this, I'm going to get 1 by 4, 15 by 8 ln, that's going to be 13 divided by 7, 13 square by 7. So I get 1 by 4, 15 by 8 and ln 13 square by 7, for which we get 6.21997. That's a very big value, but it was stated we're supposed to keep our answer to 3 significant figure. So I can write we get actually 6.2199, but if I want to convert this into 2 significant figure, it's going to be 6.22, right? And after this, I was trying to find out the value for your T6. Now I cannot just jump to T6. I have to then calculate T3, T4, T5 like this. So for this next one, this is your T2. Then for the next one, we are going to find out T2 plus 1. It is going to be 1 by 4 plus 15 by 8 ln 2 multiplied with this value 6.221 whole square divided by 6.22 plus 1 and then a bracket. Now I'm not going to simplify it further. I'm just going to write 1 by 4 plus 15 by 8 ln, then inside that 2 into 6.22 plus 1 square in 7.22 actually in the denominator. And you get the value for your T3 as 6.29. Then same thing, 3 plus 1, this is going to give you the value for your T4, 1 by 4 plus 5, 15 by 8 ln 2, 6.29 plus 1 plus 1, right? So you have already written that entire expression in your calculator. So you just have to change the value for that 6.22 to 6.29 and that will be enough. So you get from there 6.31. This is the value for your T4, right? This was T2, T3, T4. I should write this down. This is actually T3. This is your T4. Then T5 is going to be T4 plus 1, which is 1 by 4, 15 by 8 ln 2, 6.31 plus 1 square divided by 6.31 plus 1. And now again, if I just introduce 6.31 inside the same expression that is already written in my calculator, so I get 6.31 again. So I can clearly see T6 is also going to be 6.31. T5 plus 1, 1 by 4, 15 by 8 ln 2 6.31 plus 1 whole square divided by 31 plus 1. So this is also going to be 6.31. So you get the value for your 4 as 6.31. Sorry, am I supposed to keep my answer in 3 significant? Okay, it was in 3 decimal place, not in significant. But the answer is going to be very similar. This is going to be 0. So there I'm going to keep 220. This is going to be some value, but final answer is going to be 4, right? So within this values, you're supposed to just change that to 3 decimal places. Do not keep your answer to two decimal places. Just 1 minute. Let me just change that. There I was getting 287. For 287, I was getting 317. So for that 317, I am getting 315. For which I get 314, right? So this is your final answer. Okay, so now we got the value for T2 and T6. This was the part D. After this, for your part E, if we move, they are saying that hence according to the model, how many months it takes in total for when the company started trading for it to make a profit. Okay, for it to make a profit means that I have to find out for how many times it was giving you the same values. Sorry, giving you a positive value then. According to the model, how many months it takes in total for from when the company started trading and then from where it makes a profit. This is your information. Like from this repetitive process you can get that 6.31, 6.31, 6.31. You're getting that as a repetitive answer, right? So you get this 6.314 is a repetitive matter, right? Like again, what was the time was in years, right? 6.314, this is where like whenever from that point you are getting a repetitive value like 6.31, 6.31, 6.31. That means from this part, from T4, you're actually making a profit. So from T4, if you're actually making a profit, the repetitive value is 6.31. 6.31 years. That means after 6.31 years, your company was making profit. And in 1 year, how many months there are? 12 months. So you just have to write 6.31 into 12, and that becomes 75.72 months, which is approximately 76 months, right? If you round that up. So for part E, that is a very simple part. You just have to write time. Now we're trying to find out time in months, right? But in the question, we got the time in years. And I can see that the repetitive part here is 6.31 into 12, which is 75.72. That is approximately 76 months. So I can accept 76 months over here. After 76 months of trading, the company will again try to make profit, right? So this was it for your October 22. I hope this was clear for everyone. We are done with your October 22, right? Yeah, this is your part A. This is your part B is written over here. All this thing is part B. Then this is your part C. Like up to this is your part C. Then the iteration is your part D, and the last process is your part E, right? So we are done with your October 22 numerical methods. Let's move on to the next part, which is your January 23 iterations. For this January 23 also, this is your question 9. Okay, if you start with this one, then again it says that y is equals to 3 plus 4 e power x square root. So you have to find out dy by dx. This is not entirely iteration. This is simple differentiation also. So I have to find out the differentiation y 3 plus 4 e power x square whole power root. That means basically I have to use the chain rule here. For part A, the equation was y 3 plus 4 ex square with a power of half. That means if I want to differentiate this dy by dx, it's going to be half 3 plus 4 ex square with the power of negative half, right? Half minus 1 is negative half. And inside the brackets, if you differentiate when 3 will become 0. And when you differentiate ex square, it actually becomes how much? 2x, right? So over here, you get actually your 2x multiplied with 4ex square. Now if you multiply this and this cancels out, leaving you with your 4x ex square with 3 plus 4ex square power negative half. And this is your expression, right? After part A, let's move on to your part B. In part B, they are saying that point P with x coordinate alpha lies on C, and given that tangent to C at P passes through the origin, that means there's already one coordinate 0, 0, figure 3, and show that x equals to alpha is a solution for this equation. X equals to alpha is a solution for this equation means, tangent and curve, they all have the same equation, right? So I have to somehow extract this equation because I only have the exponent of that point P alpha, right? Inserting another alphabet into an equation will not give me any solution. So I have to somehow extract this equation using the gradient formulas. Like this is how we're going to carry on. For part B, I know the gradient for the curve C, gradient for curve C is already given as your dy by dx as 4x ex square and 3 plus 4ex square with a power of negative half, right? And this is the gradient for your curve C. Now with this value, I can also find out the gradient for your tangent. Now you have to understand that for the tangent, 1 minute. This point P also passes through this line, right? Which is what? Y is equals to x over here. You can see this is an equation for y is equals to x. If this is the equation is y is equals to x, and what was the equation for y? You can now consider this in this way, that for part gradient of tangent, which was also passing through the origin, which is at 0, 0, we can write this equation as y minus 0, and then again your gradient over here, like whatever the value for the gradient that you get, gradient this x minus 0. If you make this equation, m becomes y over x. What was the value for y? The value for y was this one. So you can write that the gradient for the tangent is actually equals to 3 plus 4ex square with a power of half divided by x, right? Now again you have to understand that gradient and tangent, so gradient for tangent and curve are always equal because they are parallel to each other. So curve parallel to tangent, that means they both have the same gradient. If they both have the same gradient, then I can write that this is my equation 1 and this is my equation 2. So equation 1 and equation 2 can actually be equal to each other. So dy, or I can say m is equals to dy by dx. If that's the case, then m is 3 plus 4 exponential x power half divided by x, and that is equals to your 4x ex square 3 plus 4 exponential x square power with a negative half, right? Now after this you just have to simplify this equation. If I want to simplify this, I can do cross multiplication. I can do cross multiplication, so it will be 3 plus 4e power x square with the power half. positive half. And if you take this x to the right hand side, you basically have 4x square e power x square, then 3 plus, and again with the power of negative half means what? That actually belongs to the denominator, right? So this x square divided by your 3 plus 4ex square with the power of half. Now if you take this to the right hand side, you basically have 3 plus 4 exponential x square power half, multiplying this with 3 plus 4 exponential x square power half, and this is equals to 4x square ex power 2. Now same thing with the power of half means that I can take the base common and add the powers. Half plus half will be 1. So now you have 3 plus 4ex square, everything with the power of 1 is not significant to write that, and 4x square ex square. Finally, if I take all these things to the right hand side and then flip the equation, it will be 4x square ex square minus 4ex square minus 3 equals to 0, right? And that is your case, right? That is the equation that I was supposed to show. In this entire part, in part B, they were asking that you need to show that show that x equals to p is a solution for this equation, and x equals to p is a solution for what equation? X equals to p was supposed to be the solution for the intersecting equation of the tangent and curve, right? So I got this equation after intersecting the gradient of the tangent and curve. So obviously x equals to alpha is going to be the solution for this equation. This is how we are going to calculate this. I cannot insert alpha into any random equation and we won't get any value because alpha is itself unknown, right? So that's why my idea was that since point P was the intersecting point of my curve and tangent, so that means I'm going to write an expression for curve equals to tangent, and that equation solution is going to be the x-coordinate of P. But since I do not have the equation for the tangent, so we're going to use the equation for the gradient and the equation for the curve to get to the finally intersecting equation. Now this is the finally intersecting equation, and the solution for the intersecting equation will only give you the value for alpha, because this intersecting equation is the combination of curve and straight line, and curve and straight line was only intersecting at one point because the straight line was not a normal straight line here. The straight line was the tangent. Curve and tangent always comes in contact at only one point. So this is the working. Then after this, for part C, hence show that alpha lies between 1 and 2. Alpha lies between 1 and 2 means that I have to now find out the value for f1 and f2, right? Because I know exactly at point P, I can understand that, okay, 1 minute. Alpha lies between 1 and 2. Yeah, because this is actually also not the normal gradient equation. This is the equation for the this is not the normal intersecting equation. This is also the equation for the gradient. And at gradient, your fx, at gradient, your your value for gradient is always 0. That is your hint that in this case, wherever at this point when x equals to alpha, your gradient was 0. So you have to write this down over here. For part C, we got the equation. I'm going to write this as f of x, 4x square ex power 2 minus 4e x power 2 minus 3. So you have to write when x equals to alpha, then your f alpha was 0. That was the case. So if I'm going to insert x equals to 1, which is going to be f1 4 e1 square 4e1 square minus 3, you are going to get your answer as minus 3 here. And if I'm going to insert f equals to 2, so you get 4 e2 square 4e2 square minus 3, and that is actually 652. Again, if you write down this in a straight line, you get that when x equals to 1, your f1 became minus 3, and when your x equals to 2, then your f2 became 652. That means somewhere in between this there is a sign change happening, right, from minus to positive. That means obviously somewhere over here when the value for x is equals to alpha, that is where you got f alpha as 0. So this is the solution, right? So we have to say that there is a change in sign and fx is constant, and hence as fx is continuous, so the value of x equals to alpha must lie within the range of 1 and 2, right? This is like the same statement we wrote for the previous maths, like this one, this statement. I'm just going to change the terms over here, like change the numbers and variables, otherwise the statement is entirely same over here again. There's a sign change, and hence p, instead of p I'm going to write hence fx is continuous on 1 and 2, so the value of x, or value of alpha, when f alpha is 0 must lie within 1 and 2 again, right? The same statement, only the variables and numbers are just going to get changed. This is it for part C. If we now move on to part D and next parts. For part D, it says that show that the equation in part B can be written in this format. I mean, I just have to do what? Factorize this now, right? Right, so for part D, I'm working with the equation 4x square ex square, then 4 e power x square minus 3 0. Right, this was the equation. In this case, I should have not just 1 minute. 4x square, then right, yeah, I'm going to consider this, that if I take 4x square ex square to the left hand side and write 3 plus 4e x square to the right hand side, and from there if I just keep x square common, it will be 3 plus 4e x square divided by 4e x square. From there, if I take e power x square common, then we have e x square common. Then from 4 I will just get 4 here, and from 3 I will get 3e power minus x square, right? This is what I'm supposed to get, because it didn't had actually e power x square, so it will get divided with that. So that's why that 3ex square in fractions or in decimals will be, or in one line it will be a negative power. And in the denominator we already have our 4e x square. The main reason for taking that ex square as a common factor is that so that we could eliminate that, and now we can write this as 1 by 4 plus 3 exponential minus x square, negative exponential minus x square. But then again, 1 minute. Oh, this is all this time, this is equals to x square, right? So I can take this square and write it on the, and take it on the right hand side. It will be a root now. Root of 1 by 4 is going to be 2. So you get the value for your x as half 4 plus 3 exponential minus x square, and everything inside this is under the brackets, right? So this is it. Other than that, nothing else. We're done with your part D. That's what we had to show over here, and this is it actually. Yeah, that's it. Now if we move on to this part E, part E says that this is the equation for iteration. X1 is 1, and you need to use to find an approximate for alpha. First calculate x3 and then alpha. 4 decimal places you have to keep your answers to. So let's start. I want to find out x3, right? Doesn't have much space. 1 minute. Since I don't have much space, I'm going to use this blank space over here. This is your Jan 23 question 9, part E1. Okay, so we are going to find out T1 plus 1, that is over here 1 by 2, 4 plus 3 exponential, it will be minus 1 square and everything under the square root. From there I'm going to get 1 by 2 root over 4 plus 3 minus exponential minus 1 square, and that gives you the value of 1.1296. So you get the value for 2 as 1.1296. Okay, and then again after this, if I want to find out I3, I'll have to continue with this as 2 plus 1. So half 4 plus 3e minus 1.1296 square, and then everything under the square root. So I'm going to get 1.1296 square, which is now going to be 1.0997. This is your T3, right? But now they were asking for T6 also. I mean, sorry, not exactly T6. They were also asking for to calculate the value for your alpha, right? So the value for your alpha is going to be that, you have to continue this until or unless you get the same value over and over again. So I'm going to continue for T4. That's going to be 3 plus 1 and 1 plus 4, sorry, 2, 4 plus 3 exponential. 4 is going to be 1.0997 whole square negative everything under the square root. That gives you 0.997, 1.1063. So you get 1.1063. Then again for T5, you get T5, sorry, 4 plus 1, that's going to be half. 4 plus 3 exponential 1.1063 square with the square root, and you just have to write this on your calculator then. 1.1063 square, which is 1.1048. And again for T6, you have T5 plus 1, which is half. 4 plus 3 exponential 1.1048 square, that is going to be 1.1051. For T7, so which is, this one is also 1.1051. I already got my answer, right? Since two of my values got repeated as 1.1051, that means this is the value for my alpha. So finally I can write that now by approximation, we calculated the value for alpha as 1.1051, and this is how you're supposed to calculate any unknown values over here. So this is it. We are done with your Jan 23 also. This is part E. Then there you have your part A and B. So B is all these values, right? B is all this part. So far this is B. That was A. Then after this, this is like this portion is C, and then this portion is D, right? This question was actually very lengthy, to be honest, but not that much difficult over here. Then if we move, this is from June 23, question 1. Okay, very small question. It says that this is the equation, and we need to show that gx is equals to 0 has a root of alpha within this range. Like the same thing, I have to just value g3, g4, and within that there will be a change of sign continuous, and hence the root will be in the range of 3, 4. That's just it. So for part A, I have to calculate g3, which is going to be 3 power 6 plus 2, 3 minus 1000. That is going to be minus 265, and then again g4, which is 4 power 6 plus 2, 4 minus 1000. This is going to be 3004, right? So you can see that there is a change of sign, and hence that gx, and as that hence gx was continuous, so obviously the root must lie within the range of 3 and 4. So we can say that there is a sign change, or I think I have that statement entirely copied over here. Yeah, this one exactly. And we're going to write gx over here is continuous. Range was 3 and 4, 3 and 4, not t. This time alpha again, and gx is equals to 0, right? The same statement I'm going to repeat every time. After this, using the iteration, calculate this. It is already stated that x1 is 3. So 4 decimal place, find x2. So for part B, x1 plus 1, it's going to be 1000 minus 2x1 root, right? So 1000 minus 2, 3 with the root over. This is going to give you the value for your x2, which is actually your 3.1591, 4 decimal place. This is the working for your part 1, and then they're asking that by repeated iteration, find the value for your alpha. Answer should be in 4 decimal place. That means I have to continue for T4, T5, T3, all these values. So not T, X value actually. X, I have to continue this for X3, which is X2 plus 1. That's going to be 1000. So this is a cube power 6 it was. To 3.1591 with the power of 6. So you have 1000 to 3.1591. You get 3.1589. Then x4, x3 plus 1, it's 1000, 3.1589, 351589 again. I mean, I got my repeated value already, right? I don't need to continue for like 4 or 5 values. This is my repeated value, so this is the value from your alpha. Alpha is 3.1589, and that is your answer then. So we are done with your June 23 question 1. This is all the working you need to do. If you quickly move on to your next question, this is from October 23, question 1. They're also the same thing they're saying, right? F x equals to 0 for the alpha. So for this thing, I again have to calculate f1, which is going to be 1 square minus 5 1 plus e to the power of 1. That's going to give me some value. So 1 plus, say 1 minus 5 plus exponential 1. There you get your answer as negative 1.282. And for your f2, if you calculate 2 square minus 5 2 e square. 2 square actually is now how much? 4 minus 10 plus exponential square. That leaves you with 1.389. And this is it. After this, I have to now write that same statement again, right? I can clearly see there is a change in sign, and hence p as, not p, f of x as continuous within the range of 1 and 2. So the value of x when f of x is 0 must lie within the range 1 and 2. Now after this, you have to do the iteration process. For iteration, x1 is 1, find the value of x2, 4 decimal places. So 5 1 e to the power of xn. Okay, so for part b1, we are calculating x1 plus 1, which is 5 1. Xn was 1, so you'll have 1 and e to the power of 1, everything under the square root, and that gives you the value for your x2 as root over 5 plus exponential power 1, that is 2.7782. And after this, I have to use repeated iteration to find out the value for your alpha to 4 decimal places. So again, you have to do the same procedure. x3, which is x2 plus 1, which is 5, 2.7782 e power 2.7782, everything under the square root, and that's going to be 2.7782, 2.7782. You get 5.4755. Then again for x4, x3 plus 1, 5, 5.4755, 5.4755, and again do the repetition, 5.4755 and 4755. You get, okay, I'm getting some different values actually. I mean, these are very big values for an iteration, like 5 and 16. These are not that they are not going to give me like repeated value. I'm actually maybe making some mistake. Let me check. 5 minus exponential power 1. Yeah, we made a mistake there. I was supposed to get 1.5105 and I'm supposed to insert 1.5105 here. So which is going to give me 5105 0.5105. This is going to give me 1.7388 1.7388, that is 1.7331, 1.7331, yeah, 1.7331. You get 1.7342. You get 1.73395, so we can write 1.7340. And then after this, if I continue for 761, I'm going to get the same value, 1.7340. So in that case, alpha, the value for alpha is actually 1.7340, right? Because from this, the last two is repeated data. So this is a same value. So this is it. We are done with your October 23 also. That's your part 1 and 2. If we move on to your next question, this is from January 24. There again, they're saying F0 for which alpha, within the range of 2 and 3. So similar thing, I'll just do the maths over here. F2 is just going to be 2 power 4, then 5 2 square plus 4 2 minus 7, which is actually minus 3, and then again F3, 3 power 4, 5 3 square, 4 3 minus 7, and that is 41. So I can see there's a change in sign from minus to positive, so obviously it must lie within the range of 2 and 3. Okay, I'm not going to write down the statement anymore because I already wrote that for all the 4 answers. Then show that the fx equals to 0 can be written in this format. Okay, x power 4 minus 5x squared plus 4x minus 7, right? Okay, I mean over here there's a power of 3 only. That means yeah, maybe okay, let's just this is just normal simple side changing procedure, actually nothing that much difficult. For part B, we were starting with x power 4 5x squared plus 4x minus 7 0, I'm going to take that 7 to the right hand side first. So we are left out with 4, 5x square plus 4x, 7, and then I'm taking 1x as a common factor, so x power 3, 5x plus 4, 7. So you get x power 3, 5x plus 4, 7 by x, and then we are taking everything to the right hand side, so x cube, then 5x minus 4 plus 7 by x. I'm doing the LCM on the right hand side, x power 3, 5x square minus 4x plus 7 divided by x, and taking this 3 to the right hand side, which is going to be a cube now. And this is exactly what I was supposed to show, right? So we have proved that. You're done with your part B. Then for your part C, it says that this is the equation for the iteration, and when x1 is equals to 8 to 4 decimal places, find x2. Okay, so we can do that over here entirely. Now for your part C1, it says that x1 was 2, so we are using that x1 plus 1, which is 5 2 square minus 4 2 plus 7 divided by 2 square root, and that gives you 3.0822. According to 4 decimal places, this is 3.0822. Okay, making any mistake. 1 minute. 5 2 square minus 4 2 plus 8 divided by 2 root. Oh, sorry, this is a cube root. Didn't saw that. And then you get 2.1179. That is the value for your x2. x2 is 2.1179. So you got the value for your C1. Then for your C2, find the value for alpha, 4 decimal place by repeated iteration again, right? So for part 2, you have to calculate x3, which is x2 plus 1, which is again 5, 2.1179 square, 4, 2.1179 plus 7 divided by 2.1179, everything under the cube root. So if you now insert that, 1179, 1179, 1179 whole square, you get 2.1468. So from here you get 2.1468, and then again x4 is x3 plus 1, 5, 2.1468 whole square, 4, 2.1468 plus 7 divided by your 2.1468 cube root, 2.1468, 468, 468. So you get 2.1541, 1541, yeah. Then again x5 is x4 plus 1, 5, 2.1541, 4, 2.1541, 1541, and then you get 541, 541, 541, which is 2.1559, I have to continue with this x6 also. X5 plus 1, which is 5, 2.1559 whole square, 41559 plus 7 square root, and there again 5959. From there you write, you get 2.1563. So you can continue this for 7. All this time we had a cube root there, right? Sorry, I forgot to write this for the last 3 times. But the calculation was correct. 563, 63 and 63. You get 2.1564. The next one is 8. You get your answer as 2.1565. And if again calculate this, you're also going to get 1565. That means you got the repeated answer for x8 and x9. That means your alpha is 2.1565 according to 4 decimal places, right? This was the only iteration maths where I had to calculate till x9. Other than that, all the other questions would end at x4 and 6 only. So yeah, this is it for your Jan 23 or Jan 24 also. I couldn't find any questions from June 24 for this iterations, numerical method. So that's why we are ending this topic wise for this numerical methods to this part. And again, if you guys are interested to buying this worksheet that we solved in the video, you can WhatsApp us in our WhatsApp number, or if you want the booklet where you can get all the questions from 2014 to 2024, you can again WhatsApp us in the same WhatsApp. So thank you for watching.